Okay, we're on lesson 6 of module 3. This will be the last lesson that you need to do before you take the mid-module assessment. There will also be a video for lesson 7, but as I said in class, it's optional, so you can watch the video, do part of the problem set, just watch the video, don't do the problem set, or do the whole thing. So it's your choice based on how much time you have. So you might want to spend more than one day on the mid-module assessment, and that would be fine. Okay, so as I said, the title of this lesson is Dilations on the Coordinate Plane. And so we will be doing dilations again, as we've been for the first several lessons of this module, but we're going to describe the dilations in terms of their, let me get something, in terms of their x, y coordinates. So if I have a dilated point, or a point on the plane xy, and I want to find its dilation under some scale factor, we're going to talk about how we would describe the coordinates of the dilated point. Okay, let's look at an example of that. Okay, so this first example looks very similar to the examples we were doing in lesson 5 on the grid, on grid paper. So here in this diagram we have some points. We have point A and point B, which have been dilated by a scale factor of 2. And the center of our dilation is the origin right over here, O. Center of dilation is the origin. Okay, and so everything we talk about in this lesson is going to assume that the center of dilation is the origin. None of this will work unless our center is the origin on the coordinate plane. Okay, enough said. So I want you to look at this graph. And as I said, it's a scale factor of 2. These 2 points, A and B, have been dilated. And they're, so here's A and B. They've been dilated to A prime and B prime. So you can think about how we did that in lesson 5. We started with a point A. We dropped a line straight down to the x-axis and got our point B. And then we scaled that one up. So here's B at 3 units from the origin. So B prime is 6 units. And by the converse of the fundamental theorem, we know that these 2 dilated segments are going to be parallel. So we can just draw the parallel line straight up and realize that that parallel line is going to cross the ray coming out OA, and we can find A prime that way. And so we did that. So what I want you to notice is the coordinates of these 2 points, A and A prime. For that matter, you can look at the coordinates of B and B prime as well, although they're not labeled. We've got 3, 0 and 6, 0 for the coordinates of B and B prime. Okay, so I want you to just look at that and think about the effect that the dilation has on the coordinates of the points. Okay, so you can pause and look at that. I'm going to show you one more example so you can check your idea. Okay, if you have an idea about what's happening to the coordinates of the points, you could check your idea on this graph. So this graph is again, the center of dilation is the origin, or the point 0, 0. And the dilation here has a scale factor of 4. So we have point A right here at coordinates 3, 3. X is 3, Y is 3. And out here we have A prime, which is at coordinates 12, 12. So that's our dilated point there. Coordinates of B are 3, 0, and coordinates of B prime are 12, 0. So there's B and B prime. Okay, so does the rule that you came up with for the first graph, is it working here? Okay, so let's look at yet another example. This example is also from lesson 5. And remember, we were given a point A and told we had a dilation with center O and a scale factor of 2. So I'm going to put that R equals 2 in this. So remember, we from our point, we decided to use the x-axis as another ray. So we dropped a line down, a segment from our original point down to the x-axis to point B. And then it was easy to see how to multiply the scale factor here. So we took this horizontal thing, and notice here that B falls on the x-axis at the x coordinate of point A. So it's at 5. We take 5 and we multiply it by 2 to get 10 to find the location of B prime. Because remember, this distance 5 needs to be multiplied by the scale factor to get the location of the dilated point. Okay, so we have it at 10, which becomes the x coordinate for our dilated point A. Okay, so we went from 5 to 10 on the x coordinate. And then to get the y coordinate, we just brought it up to the line here. But we knew from the fundamental theorem of similarity that this dilated segment would be multiplied by the scale factor to find the length of the segment between the two dilated points, A prime and B prime. So in order to get this height, we take this length, and the length of this segment, notice, is the y coordinate of A. So to get the y coordinate of A double prime, or A prime, we just multiplied by 2 and got 4. All right, so what you can see here then becomes obvious is that if the coordinates of A are 5, 2, the coordinates of A prime are 5 times 2 and 2 times 2. The original coordinates here are the 5 and the 2, and we multiplied them both by 2 to get the coordinates of A prime. Okay, this was a pretty simple example with some simple numbers where it's easy to do the math. But we have another example from lesson 5 that we'll look at now. Okay, here's the example that we had in lesson 5. We had the point 7,6, and we were told that, so we had this point 7,6, we were told we had a dilation from center 0, and that the scale factor was 11/7, and we went through the process of finding point B, multiplying this distance of 7 times the scale factor to get the point B prime, and then coming up to the line and realizing that this point right here would have to be A prime, our dilated point. And then we had to do some math to find the value of the y-coordinate. We knew it was 11 for the x-coordinate, and we knew it was a little more than 9 for the y-coordinate. And we did the math. So let's just look at how we could have found the coordinates of point A prime using what we just talked about. So A prime should be the point 7, because that's our x-coordinate, times the scale factor, 11 sevenths. That would be the x-coordinate, and then the y-coordinate would be 6 times 11 sevenths. Okay, so if we simplify that down, that is A prime would be the point 7 times 7 elevenths is just 11. And 6 times 11 sevenths is 66 sevenths, which was our approximately 9.4. Okay, so instead of going through the process that we went through, we could have just multiplied each of the coordinates by the scale factor of 11 sevenths right here. Okay, so that's kind of interesting and handy. And remember, this only works if our center of rotation is the origin. Okay, so we tested this idea of just being able to multiply the coordinates by the scale factor. We tested it for a fairly simple example in the first couple graphs that I showed you. Then we showed that it worked for that graph with a fractional scale factor. Now what we're going to look at is what would happen if the coordinates of the points weren't positive. So the coordinates of this point here, A, are the x-coordinate is -2, and the y-coordinate is 3. So we've got A is -2, 3. So we want to dilate that by a scale factor of 3. So let's let R equal 3. So we want to look at where our point would end up. So just to test this, we're going to go through the process we used in lesson 5. So I'm going to drop this line down to this point B, and our scale factor is 3, so this distance here is 2. So if I multiply that by 3, I get 6. So I'm going to go out 6 squares. Notice I'm not worrying about whether it's positive or negative. I'm just going out from the origin. And then I'm going to go up to, I'm going to draw this line up to the ray that contains the point O and A. So the ray right here containing the point O and A. So I'm going to bring my line up to meet it. Okay, and that's what we did in lesson 5 to find the coordinates of the dilated point. So it looks like the coordinates of our dilated point, so this would be A prime over here, would be, x-coordinate would be -6, and the y-coordinate would be 9. Okay, so it worked. -2 times 3 would give us -6. 3 times 3 would give us -9. Okay, now you can go ahead and work on exercises 1 through 5 independently, just practicing this idea of finding the coordinates of the dilated point directly using the scale factor. Okay, so we'll do one together. So point A is 7, 9. It's dilated from the origin by a scale factor of 6. So what are the coordinates of point A prime? Okay, so A prime would equal the point where I take 7 and multiply it by 6, and I take 9 and multiply it by 6. So it would be the point 42, 54. Okay, so go ahead and do numbers 2, 3, 4, and 5 on your own, and then we'll check those together. Okay, so here are the results for numbers 1 through 3. We already did 1 together, so for number 2, you should have gotten -4, 5 halves for the point. The scale factor was 1/2 right here, and so we just multiplied the coordinates -8 and 5, multiplied them both by 1/2, and got the point -4 and 5 halves. Okay, which if you can picture these coordinates on the coordinate plane, you can see this scale factor of 1/2 is pulling that point toward the origin. Okay, and then for number 3, we're going to multiply the coordinates, the x and y coordinates, by 3/4, scale factor of 3/4, and we're going to get 9 halves, or 4.5 for the x coordinate, and -3 halves for the y coordinate. Okay, and here are the results for 4 and 5. For number 4, D prime would have coordinates 0, 44. When we dilate, this would be a point lying on the y-axis, and its dilation is going to also be on the y-axis with an x-coordinate of 0. So 0, 44. And then point E prime would be each of those multiplied by 3 halves. So we'd have the point -3 and -15 halves, or -7.5, however you want to write that. Okay, let's look at another example. All right, so we have just been dilating points and showing what happens to the coordinates of the points under dilation around center 0, or the origin, when the center is the origin. So we can also do this with geometric figures. So here is a triangle, and the coordinates are given as -3, 4, 2, 3, and 5, 7. So it's triangle ABC. Actually, let's go ahead and label. This is A. Call this one B, and this one C. And so we're going to dilate it with a scale factor of R equal to 2. So we'll be doubling everything. So we can find B prime, which would be the point -3 times 2, comma 4 times 2. So B prime would be -6, 8. So we can go ahead and plot B prime is -6, 8, right there, pretty much. Get it in the right place. -6, 8. Okay, there we go. So there's B prime. And notice that's on a line coming out from the origin here too. We can, let me get a lighter color here. We got a light green here. So this line, this ray coming out from the origin would include both of those points. So there's B prime. So we can now find A prime. A prime would be the point, A is the point 2, 3, so A prime is going to be the point 4, 6. So we would have, let's find that point, 4, and, oh, it's right here on our triangle. Yeah, we'll go ahead and do that. 1, 2, 3, 4, and 6. That's our point A prime there. And let's find the coordinates of C prime. C prime would be the point 10, 14, because the coordinates of C are 5, 7. So we've got x is 10 and 14, so that would be right there. So our new, so this would be C prime. So our new triangle would be found by connecting those points. So let's pick a different color. Let's go purple. And we'll connect our B prime to A prime, which is right there, A prime to C prime, and then B and C. So there's our dilated triangle with a scale factor of 2. Okay, so that's kind of a rough drawing, but I think you get the idea. So we're going to do some exercises now where you are going to be given the coordinates of different figures and then dilating all the segments in the figures. By dilating the points, connecting the segments, we will see these figures coming out. And so hopefully you can see this is a similar triangle. And we'll see more about similarity in the second part of this module, lessons 8 and beyond. Okay, now that you know how to find the coordinates of a dilated point, just using the scale factor, let's go ahead and do exercises 6 through 8. You can do all 3 of them and come back and check your work quickly by the video, or you can do them one at a time if you are unsure. So remember, you're going to find the coordinates of the point, multiply by the scale factor to find the coordinates of the dilated points, and then connect the segments. Okay, so this first one is a triangle again. So pause the video and work on this and come back and check. Okay, so you can check your work on exercise 6 right here. We were just told to identify the coordinates. The graph is not big enough to plot them. So A prime, or point A, is -2, 2. You can find the coordinates right here. And I'm going to multiply each of the x and the y coordinate, each by 12, and I'll get -24, 24 for those coordinates. Okay, point B is -3, 3. Multiplying each of those by 12, I get B prime is -36, -36. And then C is the point 6, 1. And so C prime would be 6 times 12, or 72 for the x coordinate, and 6 times 1, 12 times 1 for the y coordinate. So 72, 12. So these would be the coordinates of another triangle. And if our graph was big enough, we could plot them. Okay, let's look at exercise 7. Okay, now we've got quadrilateral here, D, E, F, G, and it is going to be dilated from the origin with a scale factor of 2/3. So it should shrink a little with a scale factor less than 1. We're to identify the coordinates of the dilated figure and then draw and label figure D, E, F, G. Okay, so if you haven't done this, pause and do it. Otherwise, we'll do this one together. So the coordinates of D are -6 for x, and y is 3. G is -3, 3. E is -4, and the y coordinate of -3. And then F has an x coordinate of 5 and a y coordinate of -2. And all of these are going to be multiplied by a scale factor of r equal 2/3. So let's first find, we'll start with, we'll go alphabetical. So d prime, d prime would have coordinates -6 times 2/3 and 3 times 2/3 for y. So d prime would be -4 and 2. Okay, so I just multiplied those fractions, simplified first and then multiplied, and got -4, 2. So let's go ahead and plot that. -4 and +2 would be right here. Okay. And that is the point D prime. Okay, so let's find E prime now. So I'm going to erase over here. So E prime is going to be -4 times 2/3, which would be -8/3, and -3 times 2/3, which would be -2. Okay, so we'll locate that exact. We're going to have to estimate for 8/3. Okay, so here's our location of E prime. Whoops, wrong tool. E prime right here. Okay, and so we could even connect those points. That'd be our first segment right there. You might notice something about the segment D prime E prime and the segment D E. They are parallel. Okay, let's look at DEF. That was E prime. So F prime is going to be 5 times 2/3 and then -2 times 2/3, our scale factor. So that would be the point 10/3 or 3 1/3 and -4/3. So let's think about where that point would be. The x-coordinate is 3 1/3. 3 1/3 would be somewhere over here. So 3 1/3 and then -1 1/3. So right down in that area. Okay, so this would be point BCDF prime right there. Let me move that label, put it out here, F prime. Okay, and we can connect that segment as well, E prime, F prime, about right there. Okay, so now we have one point left to dilate, and that would be point G. So point, let's get this back big again. Point G is -3, -3. So G prime would equal -3 times 2/3 and -3 times 2/3. Okay, that one's pretty easy to do. So that becomes G prime is the point -2, -2. or oh, I'm sorry, -3, +3. So this one is, the y coordinate is positive. So it would be -2, 2. So -2 and +2. So we'll get a dot right there. It's hard to get them exactly in the right spot. Okay, so there's -2, 2. So we can connect, now we can connect our remaining sides. So we've got segment D, G prime right there, and let's label this G prime. And then we've got G prime, F prime. So that would be right in that area right there. Okay, so that is our dilated quadrilateral, and you can see that it is a similar figure as well. It is good to notice all the parallel line segments. We've got segment EF parallel to E prime F prime right here, and so on. So we'll do more with that in further lessons as well. Okay. Okay, and you can check your work here. Pause it if you haven't done it yet. Come back and I will have the dilated triangle here for you for for problem 8. Okay, so for number 8, the calculations for the dilated points are over here on the right, and I have plotted the points on the diagram so you can check. And now I'm going to join the segments together to give us our triangle, and there you go. And so you can see that this scale factor of 1/3 is going to shrink this triangle and also pull it closer to the center of dilation here at the origin. But it is a similar triangle. Notice it's an acute triangle. You should be able to see some parallel line segments as well. For instance, look at BC and B prime C prime. Okay, so parallel segments from the dilation and also the shrinking. Okay, so you have had lots of practice with dilating points on the coordinate grid just by multiplying by the scale factor, multiplying the x coordinate and the y coordinate by the scale factor. So okay, so this concludes lesson 6, and lesson 7 is again optional, and you can go right on to the mid-module assessment after you're completed with this lesson, after you're done with this lesson. Okay, thanks, have fun, see you later.